Hey everyone, this is Raj. My full name is Raj. I'm Srinivasan. I just go by Raj. I'm the product manager for Imperva RASP. Previously, this was a solution called Privity, and we acquired the company about uh, in many, and we're moving forward from there. So let's move. Let's have a quick overview of how the solution itself looks like, because unlike WAF or DAM, we'll also try to explain what RASP as a solution is, and then speak a little bit about what Imperva RASP does, and see a quick demo of some of the capabilities before and after, and how you can predict your vulnerable applications through RASP in the process, and also go over the broader roadmap and just the bigger picture with respect to strategy that we're looking at for RASP. So if there are no further questions, let's get started with the presentation itself. Uh, Looking at modern day software security challenges, right? Like one, it's inevitable that we introduce vulnerabilities as we add new code. It happens all the time. I mean, we might have the best of secure developers. We have let's say, really good DevOps process that's validating all this as well. Even in that case, you actually don't get to control what's happening in the software supply chain. What we mean by that is very small portion of the actual application is things that are under our control. Then when we talk about the overall application package, it's not just the binary, it's the dependencies, it's libraries and other third-party vendor packages that it interacts with, and so on. And these are areas in which we often don't have a control of. Although these are like time-tested, trusted libraries, it's only a matter of time in which some vulnerability or the other is found in some of them. So we know, I mean, based on Veracode reports, 83% of websites have some kind of unknown risk with respect to third-party code. And it's long and painful process to fix these vulnerabilities. So it's almost like you know that they exist and you know that your app is made vulnerable because of that, but then it goes through its own cycle to make the fix, leaving you exposed with the vulnerability in place for an average of 171 days. This is again the statistics coming from Veracode, which is very popular in application scanning. So, and not only that, it's not just the time, it also slows your business down to be fixing vulnerabilities in these 171 days. This is not very productive work, and developers enjoy developing new applications or developing business logic much better than fixing vulnerabilities, because it keeps going into the technical debt and it takes a while to fix this. And by the time, it's almost like painting the bridge. Like by the time you fix it, there's another vulnerability that might show up or come up, and then you still need to fix it and so on. So, and this has only been made even little more, even a lot more harder with evolution of software complexity. The methods, architecture, the way we deploy software has changed significantly from the days it used to be the waterfall model. I mean, we went from waterfall with this traditional monolithic, you deploy things in a client server model and physical servers, and you owned your own data centers and stuff like that. From there to more like agile, where we talk about sprints, quick iterations, and delivering complete piece of the pie in about 2 to 4 weeks, depending on what your cycle looks like. So fairly agile, ability to add uh, ability to quickly change things around based on customer feedback. It evolved there, and then the times of virtual server and hosted kind of infrastructure came. So you're not exactly putting everything on a separate blade, but you have VMs and VM managers that can kind of take care of things there. But we moved a step further from there. We now have DevOps, which is continuous CI/CD, continuous integration and continuous development. So you have automated your entire workflow. So you can literally go from commit to production in less than a few minutes. So you commit code, it gets tested for basic unit test cases and for functional test cases. And then once it goes through like the right layers and development staging, and I mean, you can actually deploy code in production fully automated if you have the right DevOps process in less than minutes. So in such a scenario, like there are a couple of questions that comes into place. Like one is, are security teams really either slowing down the development process, or are they really missing some significant blind spots because of the rapid deployment model? So you're not able to go through the regular infosec process. You often have backlogs, but you give developers the time to fix it and so on. And again, from traditional apps, we move to microservices, which means it's a cluster of interactions. Your own application is interacting within these microservices uh, in several different ways. And also it became ubiquitous for other services to call these REST APIs or microservices, like, in any form and shape it's delivered to really deliver value. So it just became like too many small, tiny applications that have interactions within them all the time. So do I trust the other applications that are interacting with mine, like even within my network, or if it's like a third-party vendor and so on? And again, moving from virtual machines to containers, things just became more ephemeral. You're spinning things up and down all the time. So if you're just monitoring things based on IP or reputation and things like that, like it just makes it more complex if you have workloads that are disappearing. So on top of that, we talk about this is similar to the software supply chain problem that we were talking about. Like this the whole thing around the third-party libraries and so on just became a lot worse with saying that you don't own the entire stack now. Like the underlying infrastructure is hosted by someone, and application runtime and server have like popular zero-day attacks. Like it happens all the time. It's a matter of time that something else is also found. And there are open source components on which we're also going to see a demo on Struts True today, just to take one unknown vulnerability at that point of time, which gave people access to command lines. And moving from there to top 5 application attacks, like it's just we know that the topmost attack that often happens is remote command injection. And from there, as you can see, all of these are actually injection categories. If we map these to the WASP top 10 categories, like remote command injection, SQL injection, cross-site scripting, all of this counts as injection. So that's what makes applications vulnerable. And we're going to see how you can protect your applications against some of these. So what if you could lower risk and protect applications without having an army of experts that are figuring this thing out for individual applications within your organization, and without making any code changes, so you don't have like technical debt, quote unquote, to go back and fix. And like without a super complex setup and ignoring the 90% of the code, which is coming from not your own developers, but from other products that you use. The third parties, the dependency, open source libraries, and everything else that we're talking about. So that is what RASP as a solution is all about. Imperva RASP is a lightweight security agent that protects your application from inside out. When we say inside out, this gets embedded into the application itself. It gets baked into it, but without any code changes, without any intervention. You can literally do this in your CI/CD pipeline, and if you have the right processes, it's kind of a set it and forget it kind of solution. So what does RASP protect against, right? Like, so we saw injections all the time with respect to what are the top kind of things that are taken advantage of. Command injection, cross-site scripting, SQL injection, JSON and XML, CSS, even HTML, CSS injection, OGNL, more common in Java. And going to attacks, like this could lead to other things, like not just getting access to data, but even more than that, like making your services insecure through like clickjacking kind of attacks, or even unavailable for legitimate users. Similar with weakness, like weak crypto, insecure cookies and transport, weak authentication, path traversals, and so on. So this is, as you can see, most of this is aligned with the WASP top 10 and more as well. So this is everything that RASP protect against based on what you can set in your policies. So without much delay, let's go on a quick demo, but we're going to talk a lot more after the demo as well, just to see how RASP works. So Here we have a simple stocks application. It just shows a sample graph. This is not even accurate, with some sample numbers for stocks of Apple, Google, Netflix, and so on. Yeah, this is clearly fake data. I really wish Tesla was only $300 today, but yeah, that's kind of where we are. And you could search for a specific stock, and it does show the results of it. It shows the graph of it. So if I did, for example, this, it shows that. So yeah, the idea is to search for a stock just by the script, and it would show you the result and where the graph is for that one. So here we have some way of giving input to the customer, input to the application. Let's see if I can attack this in any way. Can I bring in some malicious payload? Like, is it, for example, this is a SQL injection. I'm just trying to see if this is susceptible to that. Essentially, what I'm doing is terminating the previous the command that's associated in the code itself by closing it with the code. I'm bringing in a tautology at the end of this fairly straightforward SQL injection case. So the query now becomes like, hey, where you're expecting some field is equal to something, or we're just saying like, do one is equal to one, like, just bring me everything, right? So let's see what this gets us to. So we see that it listed all the scripts that's available, like Apple, Google, Netflix, Nike, and so on. So we were able to fool the system and get all the scripts that are in the database. So a very classic SQL injection attack. You can make it even more complex by bringing in any other expressions or truism or anything of that sort and more here. So this is one, and let's see if the application is also susceptible to cross-site scripting. If I just did something simple, like do an alert on this. Okay, yeah. So I'm able to inject JavaScript into the application just through input, which is not good. Even more, I mean, this is just classic harmless to show a pop-up. I can change the behavior of the application itself. Here, all I'm saying is I'm bringing in a bullet with a JavaScript event saying like, on copy, just change this. So this looks super harmless. Like it almost looks like the actual application itself, but I've successfully changed some contents of it. And if I click on it and try to copy, I'm able to inject an attack in here, and the possibilities are endless here. Right? Like I can basically use this to show something like a password field or some other thing of the sort, and the user will be tricked into thinking that it is your legitimate web application, but it is not. They just managed to get a good grasp of what's going on, and I mean, like, to exploit what you have in the search bars. So we could go even a step further. Like we are also going to talk about command injection and so on. So let's just say I now have this. This is a simple JavaScript application, which is also based on the Acme investing stack. All it does is takes a param, tries to execute the command through OS subprocess kind of a method in Java, the equivalent of it. So we're simply going to say like, okay, so do I want to show like, the etc password, like everything within the passwd context? And I actually managed to do that because it's blindly executing whatever command it's getting, running it in the shell and throwing the results back. Now we've gotten a list of all users and their permissions in here, which is not good at all. And this is just one side of it, right? Like again, the possibilities are endless once you actually have access to their script. Like you could, for example, print all the environment variables. This is, in this case, mostly harmless stuff, but what exactly are they doing? I can not only print, I could even modify some of these variables. And if you're using, environment variables to store sensitive information, like say API private keys and stuff like that your application is using, all of this is going to be exposed just by this. So giving this basically gives an attacker open access to console that's really running the application, right? So these are types of the attacks that we see, and let's turn on Privity and let's turn on the Imperva RASP application and see what's working out. So all I'm doing here is I'm just swapping configuration. I was currently in the monitor mode. I'm making this to protect, and this is simply an automation script. Like in an ideal world, what you would do is go to the management console, you would change a lot of these to protect. Like in this case, if we are talking about SQL injection, you just go from monitor to protect, and then you simply download the configuration and upload it within your application. So what we have is a config manager. This is the management console as we talk about. Let me also quickly walk you through what's available in the management console rather than me doing a simple swap, although it's easier for orchestration. So this is the Acme investing app that we have. So let's just open that. You could add any enrichment headers that's coming from the WAF end. So you have even more data that you can dig into when an event happened. This is all in Capsula WAF headers, and we can have similar mapping for this thing as well. And there's logging format, and then you could even go a step further into develop like logging what kinds of events that you want to log into. And we also have a masking functionality for logging, so you're not really exposing sensitive information as a part of when you're logging things on the dashboard. So let's talk about the protection thing alone here, and then we could look at activities and come back to logging. So this is simply cookie protection, SQL injection, cross-site scripting, CSRF as we call it, cross-site request forgery, and so on. So this is all disabled here. All you would do is change all of them to protect. I mean, like change content injection, cross-site scripting, and so on to protect, and download a configuration and switch it back to protect. So that's kind of what I did by this like slightly automated script to switch my RASP mode to protect and made this application a little bit more secure. So let's try the classic SQL injection that we previously tried to do. And it now doesn't return any results whatsoever. So, and it does throw an exception. This you could handle within your app in ways possible, or that's also okay too. So you're just simply getting a multiple statements exception because you're trying to bypass what was given in the script and you're trying to add more. So this gets logged into a Splunk dashboard, and this can literally go anywhere. You could use any of the others SIM applications. For today's demo, we're going to use the Splunk app. We have Imperva RASP Splunk app as well, and there's a new app for 4.0, which we're going to talk about. So quickly getting in here, we see that this is the summary dashboard that we're talking about. It shows all the requests that were processed and about 21 different attacks. So let's go over what it looks like, right? So this is the SQL injection that I just entered, and pretty much every other thing that I did is in over here. And for example, here you get to see what was actually bypassed by that single quote or 1 is equal to 1. So the actual query that was executed from the application was select name from stocks where name is equal to something. This is where it was expecting the legitimate name. We just bypassed that and did another tautology on the side of things. So the same thing with a lot of these other stuff, like every other command injection or cross-site scripting that we tried is all over here. So let's go to very simple the SQL injection itself that we started out with, and see what exactly do we actually get to see. First is the action is blocked, so rest assured, like no damage done if you're looking at it from a SOC side of things. And then you get to know what was the cookies that was present at that point of time. I'm using Chrome, so you do have the anti-CSOFs token. And you have the session, you have everything else that was in the cookie at that point. So it logs the entire cookie. And the application is using MySQL. We're changing things from IP, we also have the IP, the port number, and everything that was logged. the user agent, you get the entire stack trace itself. So you literally know the precise line number where the injection happened. So you can go back and fix the code to use a more secure way of handling queries if needed. If not, otherwise it's blocked at all. So that's okay too. And this one was allowed. So these are things that we executed when things were in still the monitor mode, and it shows the full stack trace, and also gives like the context of who, what, and how this happened. Like, which host is this? What was the user behind the host, and so on. It talks specifically about what was the attack that happened. So in this case, this was SQL injection within the application Acme, and this is the actual input that was executed for whatever command that I gave in the box, the source IP and URL. So this is a lot of context to understand what's going on, both the bigger picture and the integrity details if you want to get into. So, I mean, without much more stuff to be added right on the demo, we can go back to the presentation, but this is a good chance to pause for questions if there are any before resuming back into the presentation. Chris, do you want to take some questions that's on the chat box? Yeah.
So Raj, I don't see any questions as of yet. Actually I do. So the first question, how different RASP is when compare this with WAF, and is it going to replace WAF in the future?
Great question. So we're going to cover that material in the presentation as well. So let me try and take this opportunity to explain this as it comes, right? So WAF is the way WAF works is it's primarily based on the who of the traffic. Like WAF works by, okay, is this something that I trust? Is this legit? And what exactly is it trying to do? So it's largely reputation based in the way it handles. Whereas RASP looks at the how of things as to like, I mean, WAF knows the context of how as well, but the rules and the way it performs, with the way it does the alerting is based on who is it trying to do. Like it's primarily north-south. Is it like a traffic that I do not trust, and then things get logged? Whereas RASP has the context of how being within the application. So we actually get to see every single request that's going into the application, which often may not be under the WAF's radar. This could be insiders that are really using this from within the application, not necessarily users. It could also be malicious / compromised applications that are within the infrastructure footprint, or it could be someone targeting a 0-day, for instance. The way you mitigate 0-day in WAF is you do virtual patching. You need to go update the signature, make sure that kind of traffic is filtered out, and it's prevented from accessing the application, which is great. It's always good to block traffic at the edge, but if things slip through and go further, that is really where RASP has your WAF's back. Like this is defense in depth and real. The way, for example, virtual patching or something like that would happen in RASP is it really protects 0-day without any learning, without really having to update any signature or anything of that sort. Because WAF goes by the how of things and not so much about like who's trying to do this. Like if something, like for example, there's no reason for you to be doing a tautology on SQL injection. It's fundamentally wrong. So just based on first principles, you're able to perform blocking or any other followed action. Yes, you might have insecure practices, and you could have, say, for example, some framework that is some ORM framework that has its own that brings in its own kind of tautology-based statements and so on. There are ways to whitelist it, but the best practice that we say is that there's no legitimate reason for you to be using contradictions or tautology within your SQL injection. I'm using SQL as an example because it's the simplest thing to explain, but there's a lot more that RASP protects against.
Another question, but Nikhil, if you have other questions about that, let us know. Hopefully that answered. Another question, so WAF profiling can have the same behavior or no? Yes, no?
So WAF does not do any profiling. That's the significant advantage of RASP. And we're going to talk about that later in the session as well.
Okay.
It goes by first principles. If something is fundamentally wrong, it is wrong. That's really about it. There is no learning, there is no profiling, which is advantageous because one, it's low touch. It's kind of the set and forget kind of model. So you're not really updating things, or you're not waiting on it for learn for about 30 days and then try to get to the protect mode. So that is number one. And number two is uh, the way it works is fundamentally the attack structure has not changed significantly. We use a proprietary LangSec, the LangSec algorithms that we use within our system. It really analyzes the request that's coming in as tokens and tries to understand really uh, the way the request is structured and go by that. And that gives a significant advantage in that there's no learning, there's no signatures. It's able to see contradictions right on the surface and take actions based on why your policy is set up for. That also makes this autonomous. So if it's like a machine learning based system, you ought to often have to share some of the data with customers. So this is completely a gap with RASP in its own. But we do have other integrations that are in place. Like if you're using, for example, CloudWrap and RASP together, we have something called Attack Analytics that does machine learning on the kind of attacks that you see just for giving you better visibility. It's not for the function to it's not for the software to work well in itself just so that it is learning, but that is to give you insights of, hey, I have 100,000 attacks, which ones should I focus, for example. And it's less of a problem with RASP because in a lot of cases we see that you're doing blocking, but we'll also see further down the slides what's the value of getting attack analytics and RASP together. And that also answers the WAF and RASP question slightly as well.
Okay. Yeah. Thanks, Raj, and Nikhil and Rakesh. If as we kind of go through this presentation, let us know if that answers your question, or if not, we can try to answer it even more, during the webinar. Thanks, Raj.
Thanks, Chris.
Okay.
So let's get a little bit deeper into what exactly happens under the hoods and look at a high-level architecture. And we're also going to compare WAF and RASP in this presentation as well. So underlying the engine that's under works is called it's primarily language based. It analyzes the structure of the request that's coming in and looks at the grammar of it to see what's really going on, right? So that's what LangSec is all about. And this is a sample SQL, right? Like we've basically let's say there's a query like this coming in, and this is the SQL injection attack that we saw. Like select ABC from table name where some two conditions, right? Like in this case, again, we see that they've tried to introduce a SQL injection by bringing in a tautology. So all of these, everything in the orange is a token, and we know that it's just exactly the way our database would parse this query. We go from, okay, these are the tokens. So all I know is that if there's an abstraction, select some fields from this particular table where some list of conditions separated by R. And then I break it down. What are the fields exactly? So it's one attribute, comma, another attribute. All right, that's okay. And we're looking at the table now, which is one single attribute, and that's okay. We're selecting something from the customer table. And we go into the condition. So we try to break down the condition. There's condition A or condition B, where condition A is some attribute is equal to some specific attribute, which is okay. And that's name is equal to Chris. But then the second condition is another attribute is also, some attribute is equal to something else, but it's exactly the same thing on both sides. This is just a sample of how we detect things that's coming into the request. And since we're within the application, there's no blind spot whatsoever. Everything that's going through the database driver is scanned for before it actually gets through. And so this code is by a major US retailer, which uses the product. We're going to see some more about their use cases here. So that's what we mean by the advantage of no learning. That this is, even if we don't have a risky situation today, like we know that Imperva RASP provides a layer of security that will help this moving forward. And we're going to see a demo of that as well, where you're able to achieve 0-day protection without any virtual patching, without any action or intervention from your side. You know that there's a particular vulnerability that was released, but you don't have to take action on it, which is, I think, the true north of where somebody in security would like to be there. Going a step further into architecture, we've seen the pieces of it, so let's try to actually put these together. So first, you have the RASP configurator, which we saw as a RASP manager, where you're able to turn on, turn off things, add even more stuff. So we could even go a little bit deeper into the configurator now. So for instance, let me take this, for example. This is Acme and Protect. That's the same stock application that we saw. You're able to add a lot of stuff. I mean, you're able to give data on logging stuff and also on this is basically everything that goes into the dashboard. You can control how things are, and you could do a different level of logging where all kind of events get through, and also you can choose to hide or show what you're seeing within these logs. The same thing with request and response, like what exactly do you want to allow within your applications? Like, for example, if you don't want regular HTTP traffic to be in place, if you always want SSL to be there, you can choose to do that, and so on. And the same with cookies and things like that. But what is actually more interesting is often the policies. For example, yes, we saw this application where it's a simple text box and we don't expect them to do anything more than a stock ticker symbol. But this is not the end all be all way of getting input from customers, right? Like, you often have rich text box inputs. You often have more sophisticated input methodologies that you're getting data from customers, like including like even a comment box or something like that would have some kind of formatting and stuff like that in there. And if you do something like this is also XML/HTML in one way, right? So, so that's kind of where what we mean by having content policies. Let's just say, for example, you want to do a new policy through WYSIWYG. You're able to allow specific things on these controls. Like, you could allow text formatting, like these are divs that are usually used in the basic text formatting: H1, H2, H3, H4, bold, italics, font, and things like that. And goes to content flow, images. It basically gives you a list of things that you can allow potentially if you expect to take those kind of inputs from customers. Again, the recommendation is not to go super broad, so you're still like allowing a lot of things, but to go a little bit less than that. And the same actually goes with standard content content-based fields. Like, for example, if you're using a TinyMC editor, we actually have default policies that you could use for editors like that, and which is very popular in forums and things like that. The same with rich media. You can choose to have which kind of iframes would I load, and what kind of protocols do I support from for your applications. And you could even go a step further and do this for database policy. Let's actually look at an existing database policy, which might make it easier. So this is just MySQL. Once you import a schema, you're able to say, like, through this particular application, I should be able to do only this, this, and this. So it's kind of a layer before getting to before going full-fledged with a DAM kind of a solution, which we have. This is very basic level of protecting what level of access do you want to use. For example, this Acme DB has the stocks table which you query from, and there's also a couple of other tables like users and some table that's in there. This comes through by uploading a schema. You're able to allow read, update, delete for each of these in subquery, union, and join. Not just that, you could even do like protect access at a function level, joins and for example, aggregate functions and things like that. If you don't, if you want to give a very tight restriction even over there, we could do that. And you also have the ability to do this on a column level.
Hey, Raj.
Yeah.
Couple of questions for you. Can RASP detect encoded payloads as well by default?
Yes, it does. And we could even do a demo encoded payload if we would like. So this is, for example, a classic encoded payload that we're looking at. So this is all like, basics for encoded or anything of that sort. And it's still some JavaScript that's within it. But we will be able to detect and protect on top of it. So this is now in protect mode, so it just shows what it has. But then we will be able to protect encoded text strings as well. Yes.
Okay. One other question. RASP is expected to support PHP?
A great question. So we will talk about what we added in 4.0, and we know that it's easier for us to do interpreted languages. If you have a specific need for PHP, please do contact us right after this, and we can make something work. So yeah, please do reach out to us if you have a need for PHP. As of today, it does not support PHP.
But CJ, we can make it happen, it sounds like, potentially. So
exactly.
That's all the questions.
Okay, great. So, and in terms of language support, this is what we have right now. We have versions of Java, like going all the way back to some really old versions. And we also have the .NET framework and also .NET Core, which is the open source version of .NET, of the .NET framework. We recently added support for Node.js as well, which makes addition of new interpreted languages much easier. So if you're looking for PHP, it's easily possible to do so, but please do reach out to us, and we can take a look at it. So this is just a sample app that we saw, very, very simple and straightforward, but RASP really goes anywhere and works everywhere. What we mean by that is, since it's a plugin that's embedded into the app, there are no restrictions on environment that it can work on. It could go on to legacy applications, which is written as traditional monoliths, which we've seen often is the case with .NET and Java. And something completely modern in a container world where you're spinning things up and down and also using microservices and so on. It just goes everywhere. That's super versatile. We're also going to see a little bit about what's coming in as well. We're adding other new capabilities as we speak, but this is super broad in that you've not really seen a deployment model or a type of applications being a barrier to adopting RASP. Like, it's just been there. And the biggest plus is the third-party applications. Like, you don't necessarily have to have access to the source code of the application. All you need is access to the binary to be able to deploy RASP and then that one. So there are many third-party applications that you could actually embed RASP into. So going a step further about known and unknown vulnerabilities, where we said we'll also be looking at common known vulnerabilities. This is the struts true vulnerability that came in through. This is the CVE of it. You could go look up, but this was fairly popular when it came through. And that was a nightmare in terms of 0-day, because this was something that was exposed during the deserialization process. If we look at it, it's trying to execute a command, and that opened up a lot of ways to do command injection. We were thinking of a demo for this. I think we are a little short on time, so I may not be able to do the demo on this one. Essentially, we are able to send an exploit payload and get remote access to the command line of the application itself. A command line of the host in which the application is running. Very similar to the command injection thing that we saw, but it just opens up a lot more possibility. You kind of have continuous access to the command line and see and execute things in the application's context that you're able to see data. So we'll skip this one to talk a little bit further about how the hows and broader roadmap and what came through in 4.0, and also allow us time to take questions. So we said we don't necessarily need application source code for RASP to run, right? So we're gonna talk talk about how this is instrumented or implemented. Sorry. So you have the application supply chain, which means not just your piece, it's the application dependencies and libraries, like anything that you're calling import, and then the application containers itself, such as, say, for example, Tomcat. And then all of this gets in and goes into the bytecode. This is the loader, and all you need to do is once you have the bytecode, you're changing things in the command line while executing to add Imperva RASP agent to the bytecode. And what you're actually executing is the instrumented bytecode by Imperva RASP, and it goes through the JIT compiler in this case. This is the case of Java. It's very similar for .NET and slightly similar for Node.js as well. In Node.js, you're installing a package through npm, and you do a requires, and there, boom, your application is protected. So this is all done without making any changes to the source code. All it does is instrumentation from Imperva RASP side and goes directly into the JIT compiler. So this is how we're protecting the application just a little bit under the hoods, and that's what makes the execution layer protects your hardens your application basically. So switching gears into 4.0 release, I could pause for questions before we do that, or we could do right after the what we did on the new release as well.
Yeah, as of now, there's no questions, but as people kind of think of them, post those in the chat, and then I'll make sure they're asked.
Okay, great. Sounds good. So let's get into the 4.0 release. Like we speak about this a lot because it's a full major release, including a re-architecture of the plugin itself. One is this is now much better suited for cloud native apps. We're not really, for example, it's also made lightweight in terms of memory and others as well. Where if you're working on a container with very minimal footprint that is really meant to do a very specific task, it now works seamlessly in such situations, better supported for more modern workloads. And we are also going to talk about serverless a little bit into this thing. It's what we have in beta right now, but it's, that kind of drives the roadmap of where it's coming as well. If you have an application that's running in serverless, like RASP is pretty much the only way to protect these applications. You don't own the underlying infrastructure. You don't have access to which servers is running on. It's all fully multi-tenanted. But the only way to protect it is to be a part of the application itself. We have security embedded into the application. That's exactly what RASP does. And with serverless, we've made that possible. We're also going to see a slide on that once we go through. And next is about language support. We spoke about the Node.js language support. This is available alongside Java, .NET, and .NET Core, as we spoke. And again, there's a centralized analysis engine that makes further coverage of additional interpreted languages simpler. So if you're looking at PHP, Go, or Python, and so on, we should be able to support it with not too much additional work, but we currently don't have support for it. Easier management and configuration. This is especially the case for more complex environments. If you have, very sophisticated content policies or whitelists that you need to support for, it's been made easier. Number one, there's no logging config, separate logging config file as such. It's been embedded into the same the main config. And there's also config awareness and migration. So after the 4.0 release, the config file that we spoke about in the RASP manager, it's actually, it has different key value pairs. It has a different schema, but we do have the ability to migrate a 3x config into 4.0 and add additional bells and whistles as you see necessary. And we also now have improved intelligence. This is where this is where we spoke about attack analytics. Attack analytics is really our solution to better understand what are the kind of attacks that's going in. If you have, say, a million events that's coming in, then everything goes into Splunk. You now have a huge backlog of okay, so what exactly do I go about? And then you often cannot even do just by the severity of it. a high is high, but not all lows might be lows. Like if there is, for example, a low and slow attack that's coming in, and you have somebody that's bombarding just under the threshold to trigger your sensors, but they're doing it for days together, and all of this goes into low, and you now have a million low attacks. So what attack analytics does is it has the intelligence to go and really make sense of all the attacks in a more broader picture to see, okay, it doesn't look at an attack just in the individual piece, like not to look at it as a single one, but as the whole surface itself, and to give you better trends of that. So we are introducing support for attack analytics for RASP as well. So if you have too many HTML injections that's coming in from inside or outside a source, you're now able to make better sense of it. And speaking of roadmap in terms of correlation, we are really looking at building the edge-to-end protection, as we call it. So you're now able to see in unison the events that's coming in from CloudWAF, give it one more dimension that RASP sees of the how, and now you have a much more holistic package where you're looking at the same event from two different dimensions, and that gives you a much clearer picture of what's really happening in here. And that's the correlation that we mean by edge to end, really looking at it from multiple different microscopes and the context and the bigger picture of what's happening in your systems. And we did say RASP goes anywhere and works everywhere. And we're also now introducing serverless. That's the latest environment that it protects. So it goes all the way from a traditional active monolith application that's sitting in some physical blade. From there to virtual machines, to containers, to all the way to serverless, where you don't own anything other than the function and a little bit of memory space that the function can use to run it. So we're starting this with AWS Lambda security. If you have serverless functions that are in your app, that are in your organizations, and you're looking for a way to protect or to not slow your developers down in moving to PaaS, because we're seeing that this is significant advantage for customers that do not want to own any kind of the infrastructure. It's literally business logic on just going into servers without you having to worry too much about the operations on the side of things. Looking at the bigger picture, I know we have about 8 minutes for the whole thing. So looking just at the bigger picture, when protecting all paths to data beyond RASP. So if we look at Imperva solutions as a whole, on the edge, we have CloudWAF, advanced bot protection, and DDoS that's there even before your network. Let's say a threat comes through, and then now we are within your network. And we have the WAF gateway or the on-prem WAF, which sits within your network. It's able to still purge traffic there and make sure a level of legitimate traffic goes in. And within your applications and microservices, you could embed RASP, and it goes all the way into DAM and CDS for data. So this is really what we mean by protecting all the paths to data. At the end of the day, what we're looking at is to protect your data and all the paths to it. A traditional application is one such path, but not everything, right? So this is really data in rest that everybody's trying to access, but this is all data in motion. These are things within and outside your application, outside your network, that's really trying to access the data. And this is the whole portfolio of everything that protects your application. And this is a broader strategy that we talk about. And bringing that to motion is a specific use case, user data tracking. Yeah, fine, we have this, and this, but how are we really making sense of everything put together? That's where user data tracking comes into picture. So on the edge, we know characteristics of what the traffic is looking like. For example, we know that this is a human, or for example, if it's a bot, we would know it from a bot protection solution. So this is a human that's using a mobile app with this client ID and so on with this particular IP, which happens to be a .exit node, yes. And it goes to the app enrichment agent, like the way we have RASP today. And it's able to add even more context. Like he logged in and performed this operation. He actually ran this query and accessed about 10 million records, which is great. and goes all the way to DAM. Like DAM is our database activity monitoring product, which talks about, okay, these are records that are actually PCI regulated sensitive fields. Like he's trying to access, for example, credit card information, or users with your staff from users could actually also include a field called credit card, which comes from our classification scans, where we basically classify things as sensitive or not sensitive. And then that is exactly where, I mean, that's just one role that DAM plays. And overall, if you get the insight that, okay, hey, here is Joe, he normally accesses about 10 records, but now he's trying to access 10 million. And that is also from PCI protected data. And why is he trying to use this through an application? Like if he wanted to do this for any other kind of processing, so this is really to protect attacks that somebody's trying to do under the guise of an application. Like usually your database is fairly secure. It's just super secure for outsiders that's trying to directly access the database, but it's super soft for applications because you don't want your applications to fail. Like you don't want any request to be blocked. And that is where this really comes into picture, the user data tracking use case that is enabled by RASP as well. So looking at broad RASP roadmap, we delivered a lot on Java 11, which is a new version of Java, and .NET Core 2 Plus, and we also did user data tracking, attack analytics integration, and in like the second half of this year, we actually delivered on Node.js support. We are now having a beta on AWS Lambda security. If you have serverless footprint, please do let us know, and we'd be super happy to talk to you. And the same with the re-architecture, where we said it's better for more advanced cloud-native workloads. And in terms of the future, we're really looking at better integration, similar to what we spoke about over here, and even more use cases on serverless and serverless and additional languages. So benefits of RASP, we have about 3 minutes left, so I'm going to quickly go over it and summarize at this. So just deploy faster with less risk. So you're not really going and mitigating every single vulnerability at the code level, leaving it exposed until the time you fix it. Lower TCO. So if you're really using RASP with the right kind of DevOps process, you simply put it in your CI/CD pipeline, the command line arguments, and you can kind of forget about it once you have the right practices. And that's the low TCO that we talk about. It's purely autonomous application protection. There's nothing that somebody needs to do. And 90+% of our customers put it on blocking. Like it has close to nothing in false positives, and that's the trust that we earn from our customers, that they always use this on blocking for the most part. And the standards compliance, again, this is now recommended in the latest draft of the NIST cybersecurity framework. And also it's a way to achieve PCI and GDPR compliance, just to get access to who's really accessing the data, even from an application context. And by default, you get 0-day protection with no virtual patching, no signature update straight from day one. And speaking of market leadership, we are the only leader that was recognized by Forrester when they did the new wave on runtime application self-protection. There are other vendors, but we were really called out as the only leader in the top right of the quadrant. So I would like to stop here and give the rest of the 2 minutes for conclusion. I know this was a lot of content, pretty dense, and yeah, so glad to have follow-ups, or if you need to dive even deeper into the context of what RASP does for your application, feel free to let us know. And this is, so if you are an existing FlexProtect Premier customer, you already have RASP, please reach out to your support or TAM teams to try your hands on it. There is also RASP standalone available. If you're not an existing customer, or if you're thinking of trying RASP, please do get in touch with us, and we'll be happy to walk you through the process and go through the setup from there.
Raj, thank you so much. It really was a great, a lot of good content. There is one question: is the demo available for partners? I'd like to. So Freddie, the answer is yes. I will post this onto the community either late this week or early next week for sure. And I'll send out an email to everyone that RSVP'd for the webinar. Also, you can see the link in the chat is where all of the webinars are posted. So yes, absolutely. But you can reach out to me or Raj directly, and we can get you more information if you need it. Thank you everyone for this. This is for coming, and hopefully this was helpful to you. Please post in the comments. I know you're leaving now, but just let us know if this was helpful, or if something that might need to change, or whatever you're looking for. I'm also looking for other content ideas to host, for webinars. So we do have another webinar coming up next week. So check the events section on, or participate in the events section on the community today. So thank you everyone for coming. Hopefully you liked it, and let us know if you have any other questions. Thanks, Raj. I'm going to stay on for a few minutes just to kind of capture some of the chats, but yeah, well done, man. There was a ton of content. I think maybe as you kind of get later in the role, like in the next several months, maybe we could do just a whole roadmap session on, hey, this is what's new and what's come out, demo on kind of what's new and what's come out, and then, hey, this is kind of what we're thinking from future roadmap stuff, because I do believe that customers love the roadmap sessions. See what's coming, and it's always my favorite, anyways.
That's good, Chris. Certainly, we could do that, and there's also potential to just hear from customers' feedback on the roadmap itself. So that would be awesome.
Of course, and if you feel like that, even besides the roadmap session, if there are other deeper dives that you want to go into, or if you have other folks within our organization that you go a little bit deeper into the RASP product and show certain things, would love to kind of do that too, because
yeah, we could do that. And the webinar that Peter is doing later in this month, that's also the API security one. That's going to cover a little bit of RASP as well, just in the context of security. But we could dive deeper with other demos or more advanced use cases too.
And CJ even said, "Thank, this is helpful," and yeah, and he agrees on the roadmap stuff. So, I mean, I'm trying to push the organization from the PM standpoint is to always now share a roadmap, even if it's quick. But like we have a DAM roadmap session coming up. It's going to be in late October or mid-October, and I think that one's going to be a huge hit. And then we do have a Cloud WAF roadmap session coming up as well. So I think anytime we can, do some of those, at least I think once every 6 months is probably realistic, because things change a little bit.
Yep, that's right.
So, all right. Well, I'm going to stop here. And again, Raj, thanks for coming. Thanks for presenting. And thanks, everyone, if you're still there. Thanks for coming. Really appreciate it.
Thanks, everyone.
All right. Bye-bye.
Bye.